Alright, let's say we have a car that is rounding a curve on a highway. And let's say that the radius of this curve, R, and let me put it down here where you can see it, R is equal to, say, 200 meters. And let's say that the coefficient of static friction is about 0.7, and this is for a dry road, which is typical for tires and concrete, about 0.7. So the question is, how fast can you go around that curve without slipping? The way to look at this is to look at the forces that cause the car to actually go in the curve, and that force will be pointed toward the center of the circle, and that force is the frictional force, F, which is just equal to mu times the normal force. The normal force, F sub n, is just equal to the weight of the car. We're assuming it's a level surface, so the normal force is just equal to the weight, and that represents the net force, F. F is equal to the net force, which is mu times the normal force, which is mg, and that is equal to the mass times the centripetal acceleration, v squared over r. If I look at this equation right here, the mass cancels out, which is nice, and we can say then that this means that v squared is equal to mu g r, or v is equal to the square root of mu g times r. So that means then that if we put the numbers in, and we'll assume that g is equal to 9.81 meters per second squared, v then is equal to the square root of mu, which is 0.7, times g, which is 9.81, times the radius, which is 200 meters. And that works out to be, if you put those numbers in the calculator, that works out to be about 37 meters per second, which is about 83 miles per hour.